Welcome back. We're going to be looking at Green George, the analysis of it. That's what we're going to be doing in lab this week, and I've taken some old sample data here from a few years ago, and we're going to together work on figuring out whether they made Green George or not. So to begin with, this was already, we have an error. So this is 0.0, because yours will be, 1982 molar. All right, so to begin with, they massed their sample. They got 0.2407 grams. And then they dissolved it in water and added some acid and then started titrating with the potassium permanganate. This is the purple solution. So when they went from colorless to pale pink, the amount of volume they had used for the oxalate analysis was 30.80 milliliters. Since their initial volume was 0, their actual used volume of potassium permanganate was 30.80 milliliters. So now to find the moles of potassium permanganate, we can use the molarity of the permanganate solution. So remember the 0.01982 moles per liter times, converting this to liters, 0.03080 liters. This yields I'm going to have to write way over here, 0.0006105 moles. So we now have the number of moles of permanganate we used. But how does this relate to oxalate? Remember that the equation showed us that the molar ratio of oxalate to permanganate was 5 moles, so this is the molar ratio, 5 moles of oxalate per 2 moles of permanganate. So let's see if we can figure out now how many moles of oxalate we have. So step 1 was moles of permanganate. Step 2, I'm going to bring down here and use this molar ratio. 0.0006105 moles of permanganate times the molar ratio, which was 5 moles of oxalate, per 2 moles of permanganate. My moles of permanganate cancel, and this ends up being 0.001526 moles of oxalate. So 0.001526 moles of oxalate. So that's pretty much what we need to know there. What you next did was you had used up all the oxalate in this particular reaction. So now, as you use permanganate, permanganate needs to find something else to oxidize. Well, remember, your iron was in the 3+ oxidation state up here, and so you had to use zinc to reduce it to Fe2+. Then the additional permanganate you could put in would oxidize that Fe2+ to Fe3+. So that was the second step in our titration. Remember, you used the exact same flask, so I didn't have to have a new mass. This was the mass I used for all of these titrations in this column. All right, so as you can see, the iron did not take anywhere near as much permanganate to titrate, as did the oxalate. So let's check it out. We have a volume of potassium permanganate that we used of 4.95 milliliters. Now again, we have our molarity of potassium permanganate, and be very careful now that you use 2 zeros before this one, before the 495. And when we calculate that out, we get, and I'm going to write this in scientific notation, 9.81 times 10 to the minus 5th moles of permanganate, a very, very small amount. So that again was step 1. Step 2 is going to be converting that from permanganate to iron 3+. So we're going to start out with the 9.81 times 10 to the minus 5th. Notice I only have 3 sig figs here because I only had 3 right there. Moles of permanganate. Now, the molar ratio for this second equation, I want you to look back at the equations and then come back and see, yes, it's 5 moles of iron per 1 mole of permanganate. My moles of permanganate cancel, and I end up with 4.91 times 10 to the minus 4th moles. So now I know my moles of oxalate, and I know my moles of iron. So now this is just a simple ratio. So 0.001526 moles of oxalate over 4.91 times 10 to the minus 4th moles of iron. And if you plug this into your calculator, you're going to find that this is 3.11. Again, 3 sig figs, 3 sig figs. So you're going to do this with your second and third samples as well. Remember, what I just gave you was just some old data from a couple of years ago. If you run into trouble, make sure to shoot me an email and we'll make sure to get this done correctly.